Okay, ladies, gentlemen, welcome back to Mr. Shaw's virtual classroom. Today we're going to talk about lesson, I think this is 22? Yeah, 21, 22. The days blur together. Okay, so right now we're talking about arcs, arc sectors, arc lengths, central angles. Here's some really good vocab stuff. Central angle is an angle whose vertex is at the center of the circle and whose sides contain radii of the circle, meaning the center of the angle is here, this is a radius, this is a radius. If it only went to here, it's not a central angle. If it went through, it's not a central angle. An arc is a part of a circle consisting of 2 points on the circle and the unbroken part of the circle between the 2 points. You can have an arc here. You could even have a major arc here. You cannot have an arc that goes here and then skips a step and then you'll hear more. No, it doesn't work like that. A sector, this sector right here, anybody who's ever played a first-person shooting game knows what a sector is. It's a piece. It's an area that you're supposed to guard or take care of. Well, this sector of this circle is defined by this central angle contained by this arc. You know what a radius is? You know what a circle is? If you don't, you need to go find out. All right, let me get a pencil. Let's start this. This is my first time looking at it. Same as you guys. Watching this video on arc measures, I will look at that later and I will weigh in, but all these videos have been really good so far, so I would recommend it. The value of x of the circle below. What is the value of x? Briefly explain your reasoning. Well, the measure of the arc in degrees is the exact same measure as the angle in degrees of the central angle. So 96 divided by 8 is 12. Now, the value of x must be 12 degrees because this isn't 8x degrees. So 12 degrees is correct. 12 is incorrect. I can't write today. My bad, guys. 12 degrees. Okay. Now, the area of a circle is found by the formula pi r squared. That is common knowledge. The circumference of a circle is pi d, or 2 pi r, which means 2r is d. What is d? D is diameter. R is radius. This is a really good practice to do, I'm assuming, because it's always good to practice these. Don't get these confused. They're easy to confuse. Don't confuse them. Now, here's good equations. Arc length, the measure of the central angle divided by 360. This right here, this is a proportion. I called it a portion first because people normally think about this portion of the circle, this portion of the perimeter. Because it's in a ratio, it's a proportion, but yes, it's the same thing. It's equal to the length of the arc divided by the circumference of the circle. If you know the whole circumference of the circle, this proportion of this divided by 360, because how many degrees are in a circle? 360. You can find out, and if you know the radius, you can find out exactly how far this is. What is needed today? Calculator. So, area of a sector is same thing. Measure of the central angle. So what percentage of the circle is being used up? The area of the sector divided by area of the circle. So if you know the area of the circle, you just multiply this percentage by the area of a circle. If you know the circumference of the circle and you don't know the length, you multiply this proportion by that. You play with these angles. You manipulate these equations. You manipulate them. Don't let this be harder than it is. This is actually very simple algebra. Simple meaning not complicated steps, not in-depth steps, no new material. This is older material in a new way. So when you're finding the length of an arc with a radius of 12 inches and 45-degree arc, this is what I was telling you about. We know that's 45 degrees. We know there's 360 degrees. What percent of the circle is being consumed? We don't know the length, but we do know that this is 12. Okay? Pi d. So D is 2 times this, so that's 24. That's where the 24 comes from. So all we have to do is multiply this 24 pi times this. You don't have to put pi as you can treat pi as a variable for this if you want an exact answer. So 24 times 45 is 1080 is equal to 360 divided by 360, 3. 3 pi. Roughly 9-ish. A little bit more than 9. So find the area of a sector. You can go over this problem. This is fantastic. It's the exact same numbers. That's very helpful when they use the exact same numbers. Now let's put this into practical use. When I say practical use, you may not think it's practical use, but it is. How many logos have you seen that have circles in them? That a portion of it is used. Now, arc length. I'm going to bring in this again. Arc length. So, measure of the angle divided by 360 is equal to length, arc length, divided by circumference. The area of the sector is measure of the central angle over 360 is equal to area of sector divided by area of circle. Now you can go even further and actually use the equations on the back of this, on the front of this page. Where'd they go? I must have been thinking of something else. Never mind. So let's fill in what we know. We know that this measure of the angle is 60 over 360. Simplify, 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 reduce, reduce, reduce. 60 over 360 reduces to 6 over 36, because we just get rid of that. So that's 1 over 6 is equal to, do we know the circumference? Not off the top of my head. However, we don't know the arc length, so I'm going to call that L. We don't know the arc length, but we can figure out the circumference. Pi d. This is R. Twice that is d. 20 pi. Follow? So all we have to do is do 1/6 of 20 pi. I'm going to keep this actually as a fraction. No calculator for this. So 20 times 1/6 times pi is equal to L. 20 over 6 reduces further. Inches. If you went and rounded it, it doesn't say round. If you went and rounded it, don't round until this step. Don't round until this last step. Because if you round back here, you can make a big rounding error throughout your process. 10/3 times, times pi. I'll do hundredths. Arbitrary. Now, we're going to keep the same information here. 1/6 of the circle is being consumed by this. That means if I went and did this, and did this, and did this, and did this, oh look, there's 6 slices of that pie. Now, we don't know the area of the circle, but we can figure it out by pi r squared. So, is equal to, I'm going to call it area of the sector, S for sector, over pi r squared, 100 squared, 100 r. 10 squared is 100, excuse me. Pi r squared, not r. What am I thinking? Thinking is the problem right now. Pi. So we have 100 cross multiply, so times 1/6 times pi. Why do I put pi way over here? Because Commutative property of multiplication says I can reorganize any multiplication and not change the value. 2 times 3 is equal to 3 times 2. Commutative, which means moving. Commutative property of multiplication, the moving property of multiplication. Again, I'll just reduce this, so that's 50 over 3 pi is equal to s. I prefer this, but let's say it goes and says, oh, I need inches squared. There we go, now it's correct. I need it rounded. 50 divided by 3 times pi. 52.36 inches squared is equal to the sector. That's the area of that sector. Don't let this look confusing. Start with your formula. Fill in what you know. 60 over 360. Fill in more of what you know. We know that the circumference is 20 pi because it's 2 pi r. Then we just do some simple math, pretending L and pi are both variables. We get 20 over 6. Looking at this, yes, it looks complicated. That shouldn't be complicated, that shouldn't be complicated, that shouldn't be complicated, that shouldn't be complicated. Same as over here. Starting with this, fill in what you know. One piece by one piece. How did I jump from here to here? Because I already did the math here. Oh, last problem. I'm going to use the same thing. The measure of the central angle over 360 is equal to the arc length is the arc length over, excuse me, yawn, circumference. How many people yawned because I did? Same as over here. The measure of the central angle over 360 is equal to area of a sector, area of the circle. Fill in what you know. How many degrees in this arc? 150. 150 over 360 is equal to the arc length. We don't know that. Call it L. But we do know the circumference. The radius is 3. Circumference is twice the radius times pi. 6 pi. Solve the rest. Area of a sector. We know that this is going to be 150 over 360. It reduces. We don't know the area of the sector. Do we know the area of a circle? Pi r squared. What is 3 squared? Don't say 6. 9 pi. Pi r squared. Reduce this, put it over here too. You can solve the rest. Don't let this be your Achilles heel. Bye guys. Have fun in Khan Academy.